tension member of square cross section of a side 10 mm and a Young's modulus E is to be replaced by another member of a square cross section of same length but a Young's modulus E by 2. The side of the new square cross section required to maintain the same elongation under the same load is nearly. See here, initially there is a square cross section of side 10 mm. This is a rod I have taken and his cross section is a square. Okay, so its length is L and Young's modulus is E and subjected to the tension F here, and it produces some elongation delta. Okay, delta 1, and now I replace some other bar which is of same length, and the Young's modulus is E by 2, and I applied the same force, and here also it produces some elongation. So here, to keep the delta 1 equal to delta 2 in both cases, delta 1 equal to delta 2 in both cases, then what is the new cross sectional dimension? That is what we need to find out. Okay, so here the formula is simple. So FL divided by A into E. Okay, so A1 into E1 equal to FL divided by A to E2. Okay, so here see, A1 is nothing but 10 into 10. 10 into 10 I will keep in terms of mm only, and E equal to A2 we don't know, so that is something like a x square into E2. E2 is nothing but E by 2, so it will become x equal to 200, x square equal to 200 mm. So what is the value, approximate value? So x equal to root 2 into root 100, that is a 10. So what is the value of root 2? You need to by heart this. What is the value of root 2? What is the value of root 3? All these you need to by heart. So it is something like 1.412 or something. So 1.4 root 2 is 1.41 something. So I will take only 2 digits. Then if I multiply with the 10, then it will become 14x. So 14 mm approximately. So the new side of the square is 14 mm. See, you don't need to draw all this in the examination, only for your sake of convenience. I'm explaining like this. But when you are explaining the problem, when you are practicing the problem, then you need to identify. Like, see, what is the item he is saying that equal to both. Okay, so he is telling like that elongation is the same for both, in both the cases, and what are the things that are constant and what are the things that are changing. So here L and F are constant and only E is changing, and what is the thing that you need to find out here? That is the dimensions of the cross section. So here delta equal to FL by A into E, that means FL is constant, so delta is inversely proportional to the A1, J and E. So you can directly equate that and then calculate like that. Okay, you don't need to write these many steps. Okay, so in that case what happens? If delta is the same for both cases, A1 equal to A1 E1 equal to A to E2, and directly you write like this. And what is the answer here? The answer is A here.